Hi, it's Gadget UK here again. Dead short video. This is one of those Savava Williams EPROM programmers. As you can see, I've just removed the screws. I'll show you why. Two issues with this. The first one, you can see I've just resoldered those back on there onto the other side of that. The way this is assembled, this adapter board, it's the cheapest design. Can you see what they've done? All they've done is just solder every other wire onto the connector there, and then melt some hot glue, trap it between maybe two metal plates after they've put a little glue there to squash it flat, and then presumably cut off the excess. And there was the same thing here, but I just found that after I unplugged it, I suddenly noticed like 3/4 of the ribbon were just floating off. This was at the point when I couldn't get it working. And the other thing I noticed is the VCC light stopped lighting there. I thought, what on earth's going on? I was imagining all sorts of things, like because that cable going to the other board had some dodgy connections. I started thinking, I wonder if we've got a latch-up failure here on one of these because we're lacking a +5 of the ground or something. But then I realised, after a lot of messing around, it was the connector. I just touched the connector and suddenly the LED came on here. So I thought I'd just have a look under here and see what's going on. Look at the state of it. It's horrendous. Look at this. Look at all the holes, the gaps. If I was to hazard a guess, I would think they stuck all the components through and then dipped it into a bed of solder, so that the bottom of the board was just covered with solder. That's what it looks like, because we've got hardly any solder. It's like there's loads of holes and pits and stuff. Look at that. It looks like it's not even soldered on there. And the power connector here, you can see, I thought this was just going to be the grounds, and I think it probably is, but look at this one here. This looks like a main ground because it's going to a couple of different connections. Can you see it? It's broken off. There's no way. That's what the problem is. I'm sure that's what the problem is. I'm sure it's that ground there. So yeah, I'm going to spend the next 20 minutes probably going over this and soldering any questionable points that I see. Yeah, that one being the first one. But yeah, I hope you can. It's hard to see how well it's going to come on the camera, but to me, it's absolutely awful. It's quite possibly one of the worst solder jobs I have ever seen. Some of the pins are better than others. Over here we start to look, well, I was going to say start to look alright. There's a few that aren't. But yeah, they are very cheap. I think this was about 40 quid or something, 30 or 40 quid a number of years ago. It's the only way I've got to program these at the moment. I do have a GQ4X, but I'm not sure what adapter board will support the larger chips, the 27C 322s, etc., and the 160s, 42 pin chips and things like that. Well, I've ended up going over nearly every single point on that. I've not spent ages trying to get nice symmetrical size of blobs and things, but I've just focused on pretty much all the joints. There's about 20 points on there, perhaps I haven't soldered actually. So I'll clean it all up and then we'll give it a test. But yeah, I guess you get what you pay for. That 56 ohm resistor there, did I just move that? This is one of the problems you get. It doesn't look like it's been soldered. Maybe it was soldered, and then when I hit the other side it shrunk, it fell down on that side or something. Anyway, we'll push it back through, but at least I've got a note of that on the camera now, in case that was a deliberate mod. But yeah, this is the thing, you see. If there was hardly any solder there, yeah, that would have never been making a connection from manufacture. Can't even get it to go through. Anyway, we'll solder that point. So we're all reassembled. I hope that doesn't indicate a fault, because why are all the lights on? Windows is booting, so maybe that's something to do with it. No, my luck, I've probably got a fault now. I hope it's not that resistor that was supposed to be in the down position. Yeah, I loaded the software and actually it seems to have reset it, so that's a good sign. So I'm going to stick my unibars in here actually, and we'll just verify that it's reading okay. So that wants to go in there like that. In fact, before we do that, let's change the chip type to 27C1024. I need to set the jumpers like that. And the interesting thing here, can you see this? Some IPA got on the side of the board and there was some red stuff. I was like, what's that red stuff? And it's because someone's coloured the tops of these with like a red permanent marker, because presumably they were just white dip switches. Yeah, so I'll get my red permanent marker out in a minute, and I think that's right. Those two up, the last one down. Yeah, that's right. Next part is this dodgy cable, which I haven't done anything with yet, but we can do that next. I'll probably do what they've done, just use some glue or something. I might even try and source a replacement connector if I can. Replacement cable. I don't know why those are on all the time there. Yeah, so I'm reading now. It did reset the LEDs there for a minute, and we'll soon find out, because you can tell just by looking at the ASCII of the dump there whether it's read it or not correctly, because it'll come up with the UniBIOS text there. It might even mention Rasula or RAS. If you look at the actual buffer, yeah, can you see this? I'll zoom in a little bit. There you go, Universe BIOS 3.2 by Rasula. So it's working okay now, it seems reliable. So the footage you just seen was taken ages ago actually, and I've needed to fix this again. I came to use this weekend, and yeah, it was playing up, and I spent ages, and I mean ages, like 2 hours going round in circles, blank checking various chips and finding they weren't blank, rearranging them, still weren't blank, reading them to see what's on them, getting strange bit patterns there, and thinking, oh, it must be something wrong here, you know. Swapped out the two 74HC245s here. At that point I tried dumping a UniBIOS, that worked, but then other chips wouldn't, and it came back to this cable, and I held these up with the croc clips like that, side by side, and just did a connectivity test, and 2 of the connections were not joined. So I stripped them all back off again, joined them all back up again. I had still one missing there. That got me again, you know, spent 10 minutes wondering why it still wasn't working, and then realised another one had broken off, even though I just recut them all and resoldered them. And it's because the wire inside these, they're super fragile and they're super susceptible to breaking. It needs something like that there, you know, with the glued it. And in fact, can you see that? That it's frayed. That glue needs heating up. I'll use the hot air on it and melt it just on the very edge, on the top and bottom, just get that to join up again. But I'm going to recreate that same thing on this side with a couple of you know, PC expansion slot covers here. So, you know, I'll sit it like that there, drag a load of hot glue on both sides here, and then I'll squish it between like that, let it set, and then just use the cutters to cut off the excess. So it's not going to be as clean as the other side, it's going to be a squishy mess, this, for certain. But if I just squeeze some glue onto here first, hope it doesn't set too quick. Yeah, so we'll squish a load of glue like that, then I'm going to push that down like that there, get some more over here, should be enough, and carefully squish it like that. Yeah, hopefully you can see that, and we'll just let that set. So I remove the blanking plates there. As you can see, this is what we're left with, so we can, you know, very carefully trim this just to make it a bit tidier. Yeah, it is a mess, but yeah, it always was going to be. I'd appreciate if anyone's got any better ideas. I mean, I could just have individual wires, you know, proper wired cable. That would make it a bit tidier here, but yeah, I might unclip this by trimming too much off if I'm not careful. You know, it might detach from the ribbon. I could always just heat that up again with hot air if it shrinks back a bit. Yeah, that's not too bad, I think. I don't want to interfere with that too much. Should just give it a bit of support at the point where, you know, the cable joins the connector there. That's the main purpose of this, really. It was never going to look super tidy. Yeah, I think that'll do. It's perhaps not as clean as that side, but I'm guessing that that's what they did. They had some piece of metal or something there to pour the plastic between. I'm going to heat this one up now with a bit of hot air, just to melt the very edge, just to, you know, make it a bit more secure there, I think. So we'll give that a go now. I'm just going to melt, let's say, just the very edge here, if we can. That will do. Very carefully try and turn it over. Remember that underside is still going to be a bit molten, you know, and just do the same here. What we're trying to do is just get it to bite, you know, melt and bite the end of the cable here so that it doesn't lift off super easy. And we'll just let that set. I lightly heated both sides of this as well here, just on the very edge, to try and get a bit of a better join. So we'll just let that set. I mean, it's pretty much set now, actually. In the meantime, the next thing I'm going to do is swap out these blooming sockets. This one is the main one. Because it's turn pin, it's a pain in the butt trying to get chips in and out of that, actually. This, you know, turn pin is good for securing a chip permanently. For example, on C64 boards, you know, where the original chips have been taken off and they've got like half-height legs, they're super short because they've been trimmed really short at manufacture. Putting a turn pin socket is a really good idea on those boards for that reason. If you try and push, you know, a chip, say, I don't know, a CPU from a 64 that's been removed and stick it in a socket like that, it'll keep popping out if you're not careful because the legs are so short from being trimmed off. So that's where a socket like that is super useful. The dual white ones here, that one's not so bad, but still, you know, these are getting a lot of use. Chips are going in and out, in and out, in and out. That's another way these sockets are good for that sort of thing, but they're not in terms of ease of getting the chip in and out of there. They're a pain. You know, they grip the pins super well. Something like that eventually will slacken. You know, it's quite easy to get a chip in and out of there. But nevertheless, I'm going to swap this one with a ZIF socket here, and I've ordered a 42-pin ZIF socket for there, hopefully. Yeah, they should sit side by side. So yeah, I'm going to get the desoldering station onto this now and remove that socket. So the desoldering station's up to temperature here. We'll just clean the tip. Had a bit of copper on there though. And as I say, I'm going to remove the right hand side one first. The larger chip, the larger socket is still in the post. Need a bit of extra solder on that top pin, I think. I imagine the turn pin socket is going to be a pain to remove actually, because the pins are quite thick and, you know, they absorb a fair bit of heat. Let's just get a bit more solder onto that pin there. So I removed all the solder there, I think. I'm just using the pliers here to grab 3 or 4 pins at a time and just pivot. It just kind of frees them up in case they're snapped on one side or the other, you know, joined on with a little particle there. This should hopefully free up. Often a socket like this will come straight off, but 1 or 2 of the pads on here are quite thick, I think, on the other side, you know, maybe the ground connections and things. 1 or 2 I did have to add a bit of solder and retry a few times to unblock. Let's see if that'll come off now. Yeah, there you go. There we go, socket off. Looks okay. So you can see, you know, we've got 1 or 2 there where there's still a lot of solder on this side, so we can just carefully, got to make sure I don't melt the socket by getting too close, just heat from this side and unblock that way. Yeah, that's not too bad. So I'll just try the socket. It's going to take a bit of effort this because the pins are pretty wide. I'm assuming it will accommodate a ZIF socket. You can see it's got a little mark on the here and the lines down the side, which indicates to me that it was originally designed for a ZIF socket, but yeah, it's going to take me a bit of trial and error just to get this in the right place, I think. So the other thing I would say when you're trying to do something like this is try and reverse fit it first. Can you see we've got contacts all the way through there? I mean, they're not all the way through because I haven't pushed it right down yet, but in terms of getting it aligned, you know, making sure the pins are straight, you can see from this side here we've got no clearance on either side, so you can't see what's going on. So having tested it a few times on this side here, the pins will then be totally straight, and it'll be easier then when you put it on this side to get it in position, if that makes sense, you know, because the pins, obviously, if they've been pushed through from one side, they straighten out a little bit. And obviously you will need to straighten them, don't just force it. if any are bent so they're not even anywhere near the centre of the hole there, they will come out. But I can feel like all the ones on that side there are in place, and if I just carefully move it, the ones on this side then go in as well, like that, and I can obviously push it a little bit further in, but they are tight. Yeah, can you see that? You can see the block in the holes. Each one of them is blocking the holes. They're almost through. So if I forced this down now, it would go right the way through. Yeah, that really helped me doing that, because like I say, I could then push it on from this side. It went straight into position. As you can see, all of the pins are through there. So all I need to do is make sure that's flat and then solder it in place, and that's one down. The next one could be even tighter, but if you look there, yeah, on the silk screen there's a little gap, so it might just fit. If it's the same dimensions as this one, it'll fit, but I might have to, on the new one, you know, the one that's going to go here, shave some of the edge just a little bit to get it to fit. But yeah, this will be a lot better for having ZIF sockets on there. It certainly will. So the same thing I've shown a million times before. I anchored the two corners there, made sure it's totally straight on both sides. It's as flat as that's going to go. And then we can just add some solder to each pin. Got solder containing flux here. You could add separate flux. Now the thing with these is the pins are pretty thick, sturdy things. So and obviously it's double-sided as well. So I'm adding a little bit of extra heat there. You know, giving it longer for the heat to flow and the solder to flow through to the other side. I'm not going to get nice clean points on these because, as you can see, they're kind of wide. The pins that go through there, they're really wide. Anyway, I'll spend a few minutes tidying that up afterwards. So I'll just clean up with some cotton buds and IPA. You can see I used some additional flux there actually. The pins on that socket were awful. I think it's just because it's been sat in a component tray for, I don't know, several years at least. I think it was one of Alison's that actually came from one of Alison Challis's components. Or component bags, I should say. And then I'll pour some IPA on here and brush it with a toothbrush actually to get right in between there. But I'll do that after I've got the majority of the flux off with cotton buds this way. So as I say, we'll just pour some IPA on there and have a little brush around. I will be cleaning this up again obviously when I do the other socket, but it's going to be a period of time now. I could be waiting a couple of weeks for that other socket. In terms of the video, obviously you're going to see it within a few seconds now, but yeah, I might need to use this in the meantime. So I do need to clean it up at this point before I do the other socket. So I haven't been able to source a ZIF socket 42 pin. I'm sure you can get them. Maybe if I looked on the DigiKey or somewhere, you might be able to get one, but I suspect from somewhere like that, they're going to be crazy prices, probably like $15 each or something like that, or maybe more. But rather than the turn pin, because this is a pain in the butt when you're removing, you know, you've got chips. Let me just see if I can show you. When you've got chips that have been soldered on boards like that, they've got bits of solder and stuff on there. It can be really difficult getting them in and out. So whilst one of these is not going to last forever, I could, you know, always swap it out again in future. I got these quite cheap. You know, they worked out about, I don't know, 30 pence each or something. So I'm going to remove that. Hopefully we'll be able to reuse that somewhere else in future. I'll just use the desolder station, you know, remove. You can see I added a cap here as well, just to add a little bit of suppression, decoupling. It's got a little cap on there, 10 microfarad, but it's got nothing smaller, like 100 nanofarad, so that's why I added that. You can see, you know, I did add the ZIF socket there for that one. That's no problems at all. So I'm just going to use the desolder station again, remove this and fit this one. Super tight this, you can see it's just this corner here, and the pins are all out. There is no damage there, I don't think there is. It's just the solder probably on the other side. There we go, struggling to come through the holes. So yeah, you can see there, no damaged pins on the socket, so we can reuse that, and no damaged pads on the PCB there. Yeah, so technically not required this stage here, but I figure why not clean this with some IPA anyway while we're on here. Just because then we can inspect the traces and the things where it joins the pads, just to make sure I haven't got any damage there. Because one of the things is, you know, with the socket that was there, the turn pin one, this one, in order to get the chips out, it's quite stiff, so you end up putting a screwdriver, and you can see just the little marks on the PCB here where I've done that in the past. The dip extractor is really hard with these types of sockets actually. There's a bit of solder there that could perhaps do with removing off that, but yeah, that's not too bad. I can inspect that now though, before we get the replacement socket on there. You can tell this is a cheap socket though, because it's not got a divider. It should have at least 1 or 2 dividers in the middle there just to give it some strength, but yeah, hopefully this will fit. Yeah, it's going to be quite tight on this side, I think. Yeah, sometimes you have to go over the holes, you know, like I say, a second time. You know, they're fairly free on this side here, but you can see, you know, you get the odd one that's looking a bit tight on this side here. So you have to use some desolder braid or something on that, so I might just have to do that, I think. Yeah, I just removed a few bits of solder from some of the pins here and then pushed it through. It's a little bit tight. One thing you've got to do with this type of socket when the pin holes are tight like that is just make sure it's flat all the way along, but then inspect from an angle like this and just make sure that none of these are raised, because they can get pushed out on this type of socket, you know, so you've not got very much of a pin to solder on this side, and it's obviously it's not going to make a very good connection with the chip. So yeah, again, you know, just inspect that side there. But that's all looking good, I think. So we'll just make sure it's as flat as it can be, and certainly with relation to the middle, because it's not got those dividers. It could go on there wonkily. It's got the notch at the top here, although it's not a very good notch, that is it. It's super thin, the amount of plastic that's shaved off that. So yeah, we'll just solder diagonally opposite, make sure it's straight, and then commit to soldering the other pins. There we go, no more nasty turn pin sockets. Just clean off the flux now. Yeah, it took ages to program that up. Hopefully the verifier might be a bit quicker. There we go, programmed okay. So this is like 5 years later. You can see the Willem here. There'll be another video coming up on this soon for something else, but I just thought I'd show you some of the other programmers that I've got here. And as I mentioned at the beginning of this video, you're really better off getting something like a TL866 Pro or the T48, which has superseded it. I've got a load of EPROMs here. This was, you know, very early on my channel, you know, very dusty there. Neo Geo stuff mostly. So I've got this box of Ferrero Rocher. You've been spoiling us, Ambassador, with adapters. So yeah, you can see some of the adapters, and this is the problem, that as you get into programming EPROMs, you'll find you need different programmers, because, well, this is what I found anyway. It's like I got one programmer and then found, oh, I couldn't do a certain chip, so I had to get the Willem, and then I couldn't do another chip, and I had to get another programmer, and I couldn't do another chip, and I had to get another programmer. Do you get the idea? So like a lot of these were 10, 15, well, 20, 30 quid each. I think this one was about 100, and it's hardly had any use, but there are specific chips that this will do, like Dreamcast chips, that me, the programmers, wouldn't do, but the TL866 and the T48 will probably do that stuff now. So yeah, expect a video on some of these things coming up. And with most EPROM programmers, you do need different adapters, things like this. I think this may be the one I used for the Dreamcast, or it could be one of these ones. I forget what that is now. Oh, that's for the Atari Lynx. Yeah, I have a cable, I think, that goes into that, and I can dump Atari Lynx ROMs. In fact, there's the adapter for it, look, hang on. What's that on? Oh, it's on a PCB. Yeah, this was something that came from Kerry. Yeah, you can see I bodged it. It was for programming his own Lynx cars, and I adapted it with that there to just dump things. But you can dump things in software. That was the route I ended up going down. Anyway, the bottom line is this was super reliable after doing those modifications, but I still had some teething issues with it later. But yeah, the fixing of the cable there made a massive difference. The ZIF socket was a massive difference. I still can't find a 42-pin ZIF for there. I'll go and check now, because those might now be more available on eBay. Yeah, so I hope you found that interesting. Please see the Coffee and Patreon links down below if you'd like to support the channel. Please check out the main channel, because we've got over 800 videos on that channel. I'll catch you in the next video.